Okay, so now again distance time graph. On x-axis we have time, on y-axis we have distance. On x-axis we have time, on y-axis we have distance. Okay, suppose let's uh, suppose this is our one first position, this is our second position, these are the these are few positions. Let me mark them. Suppose for x, like the coordinates of this point are, for x-axis suppose it is 5 meter distance, sorry, time in 5 seconds it traveled a distance of 10 meters. For this interval, suppose time taken is 10 seconds and the distance travel is 25. For example, for this interval time taken is 15 seconds and distance travel is 35. So now let's calculate the gradient of each interval. For example, our starting point is, this is our starting point. Now the distance, the gradient of these 2 points, the gradient of these 2 points, this is the first point is our origin. Origin has 0 0 coordinates. So gradient is m and it is equal to y2 minus y1 divided by x2 minus x1 divided by x2 minus x1. Let's apply this formula to our first interface. Like this is, let's assume that this is our y2, 10 is our y2 and 0 is our y1. So it would become 10 minus 0 and time taken was 5 and x1 would be 0. So divided by 5 minus 0. So 10 minus 0 over 5 minus 0, it would be equal to 10 divided by 5 and it is equal to 2. Okay, so you can see on y-axis we have distance. So y2 minus y1 is actually distance. So here it would be, the unit of distance is meters, and on x-axis we have time. So x2 minus x1 is actually time, and the unit of time is seconds, and unit of time is seconds. So now our unit for this gradient is meters per second, and we know that the unit meter per second is the speed's unit. So it means whenever we are going to calculate the gradient is m, gradient or slope of distance time graph, we are actually calculating speed of the object. So distance time graph is actually speed of the object. Okay, so let's calculate for second interval. Suppose the second interval is this one. So now y2 minus y1 is, y2 is 25 and y1 is 10. So 25 minus 10. So gradient is 25 minus 10 divided by x2 minus x1, 10 minus 5. x2 is 10 and x1 is 5, so it would be 10 minus 5. So we will have 20 minus 5, 20 minus 10 is 15 over 10 minus 5 is 5. So we have 15 over 5 is 3, and with 3 and its unit would be again meters per second, and meter per second is the unit of speed. It means the gradient is this one of distance time graph is speed of the object. So let's calculate for the next interval. For let's consider the third one. This one. Okay, for this interval you can see y2 minus y1 is 35 minus 25. So gradient is 35 minus 25 divided by x2 minus x1, 15 minus 10. So 35 minus 25 is 10 over 15 minus 10 is 5. So 10 divided by 5 is 2. Again, its unit would be meters per second, and the unit of, like, the gradient is actually distance over time, like the unit is meter per second, and meter per second is the unit of speed. Is the unit of meter per second. It means whenever we are going to calculate the gradient of distance time graph, we are actually calculating the speed of the object. So what is our conclusion? For a distance time graph, the gradient is actually gradient gives us speed of the object. So whenever you will calculate the gradient of distance time graph, you are actually calculating the speed of the object. So for distance time graph, the gradient gives the speed of the object.